Welcome everybody, how are you? Today we are going to talk about lesson 2 in geometry, systems of measuring angle, degree measure, radian measure. We will solve exercise 8 in المعاصر book. Question number 1. Find in terms of pi the radian measure of each of the angles whose measure are as follows. Number 1, 135 degree. We want to convert by radian. Okay, you know x degree over 180 equal theta radian over pi. You use this relation about theta degree and theta radian to convert from theta degree to theta radian. We will write here 135 over 180 equals theta radian over pi, and then we can find theta radian by multiply pi, means 135 multiply by over 180, and then you can solve by your calculator. Look at here, this calculator. We write 135 in fraction over 180 multiply by pi. We will write by here shift x again, shift, and this, okay, pi, shift, this order, x multiply n to power x, this okay, this point result will be 3 over y, 3 over 4 to 1. Question number 2. $90 degree. Write 90 over 180 multiply by pi. To convert directly, 90 over 180 equal half pi. Question number 3, 300 degree. We can divide it by 180 multiply by pi, and write in calculator. We can cancel 0, 0. 30 divided by 18, you can divide it by 6 equal 5. 18 divided by 6 equal 3. 5 over 3 pi. Question number 4, negative 235. We can divide it by 180 multiply pi. You can write calculator 235 in fraction over 180 equal 74 over 36, negative 47 over 36 pi. Question number 5, negative 210. We can divide it by 180 multiply pi. In calculator we can write 210 divided by 180. You can simplify it by your mind. Okay, the result will be negative negative 7 over 6 pi. Question number 6. Number 7. as this example. But question number 8, we will solve it because it's more than 360. So we can find the measure of angle 780 by simplest divided by 2 multiply 360 because it's more than 360. 360 multiply 2 equals 720. The result will be 60 degree. You can find the ratio between 60 over 180 multiplied by pi. We can cancel 0 by 0 and over 3 pi. Okay. Question number 2. It's inverse about this equation. Now we have the inverse. Okay, look with me here. Question number 2. Find the radian measure of each of angles whose degree measure as follows, approximating to the result to decimal place. You want to find the measure to approximate it to the 3 decimal place, to 3. Okay, first number 1, 58, we can divide it by 180 multiplied by, using a calculator to do that. We will write 58 over 180 multiply by the result will be 29 over 90 pi. You can converse it. The result will be 1.0122 approximating to 3. You want to approximate it to 3. The result to 3 decimal places. Look at 1, 2, 3, 2. Can't give 1, 2 because 2 less than 5. These digits can't give 2 any numbers. 2 will be 21.01. It's okay. And question number 2, 3, 4, 5. As this example, I will solve 6. Okay, and you will solve question number 2, 3, 4, 5. It's as these methods. Okay, look with me here. 160, right? 160 degree and 50 minute and 48 radian. Okay, we can divide it by 180 to multiply by pi. All these steps you can do it on your calculator. Okay, the result will be 2.8.73. 3 can't give 1, 2, 3. The result will be 2.807. 2.807. Okay, it was the result. It's question number 6. Okay, question number 3, then first about last question. Question number 3, find the degree measure in degrees, minutes and seconds of each of the angle whose radian measure are follows. Number 1, 11 pi over 15. You can put about pi or cancel by and write 180. it's easy for you. Again, if you want to convert this fraction to degree measure, you must cancel pi and put here 180. You can replace pi by 180 and using calculator. 11 over pi over 5, 15 multiple by 180. Our result will be 132 degree. It's a direct only, okay? Direct method about this. And question number 2, 0.72 pi. You can put or replace this pi by 180 directly, okay? You can do this directly, but if you want to convert to radian measure, you can put or replace pi by 3.14. But in this question, you want to convert to degree measure, so we will cancel pi and replace it by 180, and then using calculator we can write 0.72 in hundredth multiply by 180 in one step and put to this. Okay, the result will be 129 degree 36 minutes. Question number 3. Question number 3. 0.49 radian. Who can solve it? We have a relation between x degree or theta degree over 180 degree equal theta radian over pi. This relation combine between theta degree and theta radian, so you can put here theta degree and theta radian 0.49 radian, okay, this radian over 180 over pi. So theta degree will be, you can write 180 multiply by 0.49 hundredths over pi, and then you can find the result by calculator. Okay, look at with me here. You can write here 180 multiply by 0.49 hundredths over pi equal, and we can solve it by this here. The result will be 28 degree 4 minutes 76 seconds. It was the result. Question number 6. Number 6. -3.5 radian. We want to convert it to degree measure, so we have the relation theta degree over 180 equals theta radian over pi. Theta degree over 180 equal negative 3.5 over pi. Multiply 180 multiply by negative 3.5, it will be 7 over 2 over pi. And then we can use in calculator 180 multiply by 7 over 2 equal, and then we can divide it by shift by equal 200, write negative here, 200.5, and then we can convert to degree by minutes and seconds. Degree to 100 degree, we can write negative here, negative 200 degrees, 32 minutes 6 seconds. Question number 5. Look at here by left hand side here. Determine the degree measure and the radian measure for the central angle that subtend an arc of length L in a circle of radius R in each of the following case. Number 1, L equal 12 centimeter and radian equal 10 centimeter. Who can solve it? We know the circle and this radius has this length of arc and this theta radian. We have a relation between L and theta and R. L equals theta radian multiply by radius. Okay, so if you want to solve any questions about this length of arc or radius or theta degree, you can use this relation. It's okay for you. So in this example, you want to find theta. You want to find theta in radian. Theta radian equal length over radius. You can find the result by dividing by L over L and R. 12 over 10, the result will be 1.2 centimeter. Okay, this radian, the result will be 1.2 radian. Question number 2, L equal 14 centimeter and radius equals 7 centimeter. So we know theta radian equal L over R. L refers to length of the arc and this radian. Okay, we can find the result. 14 over 7 equal 2 radian. Theta will be 2 radian. Number 3, L equal 2 pi and 2 pi centimeter and the radius 6 centimeter. So theta radian equal length of arc L over R. 2 pi over 6, result will be pi over 3. You can use a calculator to do it. Pi shift as this button over 3. The result will be here, and you can write result by this 0. The result will be 0 over 1.04 and 7 radian. It's okay. Question number 6. Look at with me here, question number 6. Find the length of radius of the circle in which center angle theta is drawn, subtended in arc, an arc of length L in each of the following cases. Number 1, question number 6. Number 1, theta equal 9 multiplied by over 8, and theta equal 1.6. Theta will be 22.5. It's L. Theta again, theta equal 9 multiplied by over 8, and L equal 22.5 centimeter. He want to find what? L, and theta give it. Okay, he want to find the length of the radius. Okay, he want to find the radius. We know radius equal length over theta radian. The radius equal length over theta radian. 22.5 over theta radian. 9 by over 8. You can find the result. 9 by 22 first, 22.5 divided by 1/5, 9 multiply by over 8. Equal 6.3. The radius equal 6.35 in 100 centimeter. Okay, it's easy. Question number 2 in question number 6. 6.2. Look at here. Theta equal 0.767 radian, and the L equal 38.35 centimeter. Want to find the radius. We know the radius equal L over theta radian, so we can find the result by divided by this. Write with me here. 0.767 over 38.35. Okay, because it's theta radian and this the length. You can find the result by divided by 38. You can find inverse of this result. Okay, inverse will be 50. Again, we can find the result by divided by length of arc 38.35 over 0.767. The result will be 50. It was the length of the radius, 50 centimeter. Question number 3. We have theta in degree and the length equal 24.3 3 and 2 and 5. Who can solve it? We know it was a theta degree and it will be, we can convert from theta degree to theta radian. Who can solve it? We know theta radian equal 139 over 180 multiplied by pi. And using calculator, 139 divided by 180 equal, and then the result we will multiply by pi. To convert this angle from degree measure to radian measure, and this point 2.4, the result will be 2.4 and 2 radian. This radian, okay, and we have we can find the radius. The radius will be L over theta radian. L equal 24.325 divided by theta radian equal 2.42. We can use a calculator to divide it by 24.325 divided by answer equal 10 centimeter, radius 10 centimeter. Question number 7. Look at with me by left hand side. Question number 7. Look at here, find the nearest 1 decimal place of a centimeter length of an arc in a circle. Radius lengths r subtending central angle of measure theta in each of the following case. Number 1, r equal 12.5 centimeters, theta equal 1.6 radian. You can solve it, it's easy for you. And the result we will approximate or write to the nearest, approximating to 1 decimal place. By using calculator, you can find approximating the result to decimal place, 1 decimal place. Question number 7. Number 1, we know r equal 12.5 centimeter and theta 1.6 radian. We want to find L. L equals theta radian multiplied by the radius 1.6 multiplied by 12.5. We can use a calculator. (1.6) right after me or with me, okay, to know the steps. 12.5 equal 10. Okay, the result will be 10. 1.6 multiplied by 12.5, the result will be 20 centimeter. We can solve question number 4 in question 7. Number 4. Okay, we have radius 15 centimeter, theta equal 104 degree, 58 and 6 minutes. 58 minutes 6 seconds. Okay, L equal theta radian multiplied by r, but this theta degree, we can convert theta degree to theta radian. Who can solve it? We know theta radian over pi equals theta degree over 180. So theta radian will be 104 degree, 58 minutes, 6 seconds over 180 multiplied by pi. Okay, and then you can find calculator. 104 degree, 58 degree, 6 seconds over 180 equal multiply by pi. Answer shift pi. Okay, the result will be 1.8 3 and 2 radian. Then you can find that is all equal 1.832 multiplied by radian. The radius will be 15, so we can multiply the result by 15. It's okay, the result will be 27.48.606 centimeters. Okay, question number 8. Choose the correct answer or the right answer. Look with me here. Number 1. Question number 8. Number 1. Choose the angle of the measure lies on space quadrant. Look at here. Now we have 25 pi over 9 lies in the space quadrant. Look at here. We know we have 4 quadrants. First quadrant, second quadrant, third quadrant, fourth quadrant. It was x dash, y dash, x coordinate, y coordinate, x from 0 and 90 and this 180, 270 and this 360. Question number 1. 25 over 9 pi. We can cancel this pi by divided by 9 because pi equal 180. So the result will be 25 multiplied by 180 over 9. 180 over 9 equal 20. 20 multiplied by 25 equal 500 degree. We can sample it by subtract 360 because it's more than 360. So 0 subtract 0 equals 0. 0 minus 6, we can't do it. It will be 10. 10 minus 6 equal 4. 4 minus 3 equal 1. The result will be 140. It lies on, look at here, second quadrant because 140 more than 90 and less than 180. So we will choose about question number 1, letter B. Letter B, okay. Letter B. Question number 2. The angle of measure 31 pi over 6 lies on the quadrant. Look at here, 31 over 6 or here. Look at here. Number 2, 31 over 6 pi. We can moving this pi and replace it 180 over 6. 180 over 6 equals 30. We can write 0. 3 times 3 equals 9. Result will be 390. 390 more than 360 degree because because it's more than, so we can find the quadrant by first. It's more than 360, so we can find the measure of angle by subtract 360. The result will be 30 degrees, lies on the first quadrant first. So question number 3 and question number 2, we'll choose letter A here, letter A. It's okay. Question number 3, the angle of the measure lies on the quadrant. We can use a calculator in one step. Okay, look at here. You can write negative 9 multiply by shift and this here over 4. The result will be this. Okay, I will convert about pi to 180. Again, we can cancel pi. To convert it from radian to degree, because I wanted to find the quadrant, so we will moving this or cancel pi and write 180. Okay, you can do it because it was pi, so pi you can convert it by 180, and the result you can find the result by plus 360. This here كده. Understood? Negative 45, and you can find the result by 8 another time. 360, the result will be 315. 315 lies where? Lies here in the fourth quadrant. So question number 3, we'll choose where question number 3, fourth letter D. Question number 3, we'll choose letter D. Question number 4, if the degree measure is 43 degree and 12 minutes, then the radian measure is, you want to find the radian measure. Who can solve it? It's easy for you. Theta radian equal 43 degree 12 minute over 180 multiply by pi. So can write 34 degree 12 minute 180. The result will be 0.24 in hundreds. 24 in hundreds. Theta radian. We'll choose letter A about question number 4. Okay, letter A. It's here. Question number 5. Number 5, the degree measure of the angle, 8 pi over 3. Pi over 3, we can find the result. Pi will be 180 divided by 3 equals 60. The result will be 8 multiplied by 60. We can write 0. 6 multiplied by 8 equal 48. 48 more than 360. We can find the result by subtract 360. The result will be 8 minus 6 equal to, the result will be 120. where 120, look at with me here, it will be 480 first, 480, we can get it here, okay, 180, what again, 480, yes, 480 هي موجود here, 480 letter D, it's okay, 480 or 120, it's equal, but this result was in that choose letter, the choice is letter T. Question number 6. The sum of measure of angles of a quadrant in radian equals space. Two by letter A. Question number 7. Look at here again. Question number 7. Here, if the sum of measures of interior angles of a regular polygon equal 180 multiply n minus 2, where n is the number of its sides, then the measure of the interior angle in radian a regular pentagon equal. Pentagon, we know pentagon, the sum of measure of interior angle of pentagon we can find by this relation, 180 multiplied by n minus 2, n refers to number of lenses, 180 multiplied by 5 minus 2 equals 3. The result will be 3 times 8 equal 24, 4 and carry up to 1 times 3 equals 3 plus 2 equals 5, okay, 540 degree. You want to find the angle of one angle, interior angle divided by 5, 540 divided by 5, the result will be 108. You can convert this angle from degree to radian. How? By divided by 180. 108 divided 180, we can use in calculator, okay? We can write 108 over 180. The result will be 3 over 5 pi. Where question number 7, yes, it's here, letter C. The result will be 3 over 5 pi, letter C. About question number 7. Question number 7, we'll choose letter C. Letter C. About question 7. It's okay for you. Another question number 8. Question number 8. In a circle of a diameter length 12 cm, the length of the arc subtended by a center angle measures 60 equals space centimeter. Measures 60 degree. Okay, we can solve it. Look at here. We know the diameter equal, in this example, 12 centimeters, so the radius equal be 6 centimeter, it's the radius, and theta degree equals 60. You want to find the length of the arc. We know L equals theta radian multiplied by the radius. Theta radian we can convert 60 over 180 multiplied by in one step. Okay, you can solve it here in one step. Convert from theta degree to theta radian by divided by 180 and then multiply by pi, and then the result will be multiplied by 6. 6 is the radius. We can cancel 6, 0 with 0, 6 divided by 6 equal 1, 18 divided by 6 equals 3, 6 divided by 3 equal 2, the result will be 2 pi. So the result will be 2 by letter D. 2 by centimeter. We will choose letter D about question number 8. Question, another question, look at here. Question number 9. The measure of the central angle in a circle of the radius length 15 centimeter and the opposite arc length 5 pi centimeter equals base. The measure of the central angle, he want to find the theta degree in a circle radius length. The radius was 15 centimeter and L equal 5 pi. Who can find it? He wants to find theta. This theta degree, you can find theta radian by divided L and R, and then the result will be L 5 pi over 15. You can cancel this. The result will be pi over 3 radian. We can convert from theta degree to theta radian, or reverse theta radian to theta degree by cancel pi and write 180. Okay, 180 over 3. The result will be 60. The result will be 60. Okay, I will solve it again. In question number 9, we have theta degree unknown, the radius 15 centimeter, L equal 5 pi. He want to find theta radian, L over R, length of the arc divided by R. R is the radius. 5 pi over 15 equal pi over 3 radian. The result will be 60 degree. To convert from radian to theta degree, we can moving this or cancel or replacing pi to 180. The result will be 60 degree. Okay, question number 9. The result will be letter P. About question 9. Question number 10. If the measure of, again, question number 10, is the measure of one of the angle of triangle 75 and the measure of the another angle pi over 3, then the radian measure of the third. We know the sum interior of angles of triangle equal 180. So this result 75 degree, and this pi over 3, 180 over 3 equals 60. So we can find the third. 180 subtract 75 plus 60. 180 subtract 5 plus 0 equals 5. 6 plus 7 equals 13. The result will be 45. We can convert 45 from theta degree to theta radian. Okay, because he want to find the result by pi. We can write 45 over 100 multiply pi, and then the result will be 4 pi. Because 45 over 180 equal 1 over 4. The result will be pi over 4. Pi over 4 centimeter. Or degree, sorry, degree. Okay. Question number 10, letter B. Choose letter B. Question number 11. The string length of the sample pendulum is 14 centimeter, swinging in angles of measure 1 over 10 pi. This the arc's length equal space. This is the pendulum. this. The radius is 14 centimeter because it's a straight length of simple pendulum, and this angle theta equal 1/10 pi degree or radian, as you like. Okay, we want to find the length of the arc. We will write radian or degree. If you put about by 180 degrees, this will be degree, or if you cancel this by and write 3.14 hundredths, this will be radian. So L equal theta radian multiplied by radius, 14 multiplied by 10, 1/10 multiplied by. We can find the result by calculator. 1.4 multiply by. The result will be 4.39 centimeter. Okay, we'll choose letter. We want to approximate it to the nearest centimeter. That result will be 4.4. Letter P. Question 11, we choose letter P. Question number 12. ABCD, a cyclic quadrant. Measure of A equals 60 degrees in the measure of Z of C. Okay, this quadrant circle, cyclic quadrant. Each opposite angle, the sum of the measure equal 180. Each opposite angle are supplementary. Okay, so measure of angle of A, B, C, D, 60 degree. It will be 120. You want to convert by 120 divided 180 by. We cancel 0 by 0. 12 divided by 4 equals 3. 18 divided by 4 equals 6. We can again divide it by 12 divided by 14 again, divided by 6. 12 divided by 6 equals 3, equal 2. 18 divided by 6 equals 3. The result will be 2/3. 2/3 pi. About question 12, we choose letter C. Letter C. Okay. Question 13. In the opposite figure, to find the length of AB, is sufficient to get number 1. Letter A. Triangle AMB is an equilateral triangle of perimeter 30 cm only. It's true because look at here. Because this is equilateral triangle, each angle of them equals 60 degree, so this angle will be 60 degree, and the perimeter 30 centimeter, the length will be 10 centimeter, and this will be 10 centimeter, this will be 10 centimeter. So we have theta radian will be pi/3, and the radius 10 centimeter. Letter B. The circle circumference 10 pi only? No, we can't find the length of AB by this information. So the letter or the solve will be letter A. About question 13, you will choose letter A because it's a quadrilateral triangle and perimeter 30 centimeter. Question 14. The radial measure of a regular hexagon heptagon exterior angle equals 360. The radial measure of regular heptagon. In a regular, the exterior angle equals 360. You must know this information about what exterior angle, but interior angles in subtract 2 multiply 180. It's interior angle, but exterior 360. Okay, 360, it will be 2 pi. You want to find the radian measure of a regular heptagon exterior angles divided by what? Divided by 7. 2 pi divided by 7 because it's heptagon. So you will choose letter B. Again, the radial measure of a regular heptagon exterior angle, exterior will be 360 equal 2 pi radian. You can divide it by 7 to find angle, exterior angle, because the sum of interior exterior angle equals 360. Question number 15. In the opposite figure, if AB and AC, question number 15. In the opposite figure, AB and AC are two tangents with a circle, measure of angle of A5 over 12 pi, and the circular circumference 96 centimeter. Then the smaller length BC equal to space. Look at here. We know the two tangents of the circle are equal lengths because they are drawing from one point, A, B, and C. Okay, and this is M. A, B, C. We want to find the length of arc BC. First, we know measure of angle of A plus measure of angle of M equal 180 because it's perpendicular here and it's perpendicular, and the sum of measure of interior angle of this polygon 1, 2, 3 quadrilateral polygon equal 360. So measure of angle of M equal by subtract measure of angle of A 5 over 12 pi. It's okay. Measure of angle of what? Of M, because measure of angle of A plus measure of angle of M equal 180. So we can find the measure of M. Pi refers to 180. So we can write here 12 over 12 pi, subtract 5 over 12 pi. The result will be 7 over 12 pi. Okay. It's the measure of this angle, measure of angle of M. So he wants the length of this, and he give you in the example, he give you the perimeter or circumference of the circle. We know the circumference equal 96 centimeter equal 2 pi r equals 69. So the radius equal 96 over 2 pi. 96 over pi, 6 divided by 2, it's 69. Yes, 69. Sorry, again, it was 69. Okay, so the radius will be 69 or 96. It's 96 again. Circumference equal 96 centimeter. So the radius equal 96 over 2 pi. We can divide it by 2. 9 divided by 2 equal 4, and the remainder 1. 16 divided by 2 equal 8. The result will be 48 over pi centimeter. It's what? It's the radius. So we can find the length of this arc. equal what? Theta radian multiplied by radius. The radius will be, or was, 48 over pi. 48 over pi multiply theta radian. Theta radian equal theta radian 7 over 12 pi. We can write the result. It's easy. You can simplest 5 pi with pi. 48 divided by 12 equal 4. 4 times 7 equal 28. The result will be 28 centimeter. We'll choose letter C about question 15. Again, I will solve it again. Look at here. Measure of angle of M equal pi, subtract 5 over 12 by, this is a measure of A. The result will be 7 over 12 pi. Circumference equal 96 centimeter. So the radius equal 96 over 2 pi equal 48 over pi centimeter. So length equal theta radian multiplied by r equal 28 centimeter. Question number 16. The angle whose measure 30 degree plus 180 multiplied by 2n plus 1, where n belonging to z, its radian measure it is equivalent to space. You want to find what? You want to find its radian measure. About equivalent. Okay, equivalent, we can put 1 here, 30 plus 180 multiplied by 2n plus 1. Put 1 here, 1 about n. The result will be 30 plus 180 multiplied by 2 plus 1 equals 3. 30 plus 3, 3 times 8 equal 24. Write 4 and take care up 2. 1 times 3 equals 3 plus 2 equal 5. 0, 4, 7. 4 plus 7 plus 3 equals 7. This right 7 here, 770 degree. We can convert this by subtract 360 because it's more than 360. We must cancel one rotate. 0, 7, 6, 7 minus 6 equal 1, 5 minus 3 equal 2. The result will be 210. We can convert this angle about degree to radian. 210 theta radian equal 210 over 180 multiplied by pi. We can cancel 0 by 0 and divide it by 3 equal 7 equal 6. 7 over 6 pi. The letter about question number 6, we'll choose letter C. Okay, we'll choose letter C. Don't forget it. Okay, you must choose and circle you will choose. Okay, and colored it here. Okay, question C. Question number letter C. Okay, question 17 is the length of an arc in a circle equals 3 over 8 of its circumference. Then the measure of the center angle sub 10 degrees arc length degrees equal space. Okay, question number 17. I will solve it here. Look here. He gave us the length of an arc circle. Length equals 3 over 8 of its circumference multiply 2 pi or 360. Okay, the length. Since the measure of the center angle subtrahend of this angle equal what? You can find it. It's easy for you. 3 over 8 multiplied by 360. And if you want to find the measure of center angle subtend this arc, this angle equal the measure of this arc. The measure of this angle will be 3 over 8 multiplied by 360, because the length of this arc 3 over 8 of the circumference of the circle 2 pi or 360. You can use in calculator. 360 multiply by 3 over 8 equal 135 degree. It's important. You must know this information, okay? You will choose letter C. About question 17. Question number 18. The circle whose radius length is the unit length. The measure of central angle radian is space. Look at here. The radian equal 1 unit. We know L equals theta radian multiplied by the radius. So we can cancel 1 because 1 equal radius equal 1. So L equals theta radian. Again, we know L equals theta radian multiplied by radius. He give us the length of the radius equal 1 unit. So we can multiply 1 by theta radian equals theta radian. So L equals theta radian. So the length of the arc equal the central angle in the radian. Okay. Choose letter C about question number 18. Thank you, my students. I will complete this question last time. Okay. Thank you. Goodbye. You must understood these questions and study hard. Okay. Goodbye.